Hello class, in this video we are going to review for chapter 1 exam. There are 32 questions on the review. There are 30 questions on the actual exam. The questions are super similar, so I recommend you practice as many times as possible. Now let's get started. Question number 1. Use the graph to find the limit of this function when x approaches 3 from the right. The 3 is here. This is 2, this is 4, this is 3. From the right, since the function is continuous at 3, so the limit is going to be the value of the function at 3 is going to be 0 here. Okay, let me double check. So this is 2, this is 4, this is 3. From the right, this is 0. Next, question number 2. This one is to use the graph to find the limit of h as x approaches -2. -2 is right here. As you can see, the function has a hole on the curve, but the function is defined at the -2. So the limit has nothing to do with the value of the function at -2. The limit is going to be the y value of this hole, okay? So this is -2. When x approaches -2, the limit of the function is 1. 1. Let me maximize this page. Okay, next. Question number 3 is to find the limit again. The function is x squared minus 9. As you can see, the function is polynomial function. Polynomial function is continuous in a domain. The domain for any polynomial functions is all real. So that means this function is continuous at any real number. So the limit of the function at -6 will be the value of the function at -6. So what we need to do is to plug in x equals -6. -6 squared, that is 36. 36 minus 9 gives 27. So the limit is 27. All right? For polynomial functions, when we need to find a limit of a polynomial function, simply plugging in the value that x approaches. Here's -6, so you just need to plugging in -6. 36 minus 9 is 27 here. Next. And this function, we need to demonstrate. So this function is a rational function. Numerator is x squared minus 100. Denominator is x plus 10. And we're able to simplify the function. Factor the numerator, we have x minus 10 times x plus 10. The denominator is x plus 10. And we're going to cancel x plus 10 and x plus 10. All right? So this is allowed because we're looking for the limit at the -10. The limit of the function at -10 has nothing to do with the value at the -10. It's not defined. The function is not defined anyway at the -10. So we can cancel these two factors, and the function becomes x minus 10. Right? When x approaches -10, and the function approaches -10 minus 10, which is -20. Okay? So we simplify the rational function. After we simplify, the function is x minus 10. X minus 10 is continuous at -10. So when x approaches -10, the limit is the value of this expression, the simplified function. So -10 minus 10 is -20. -20. Next. Question number 5. This function is rational as well. And the numerator is a linear, degree 1. Denominator is a quadratic, degree 2. And we are looking for the limit of the function when x approaches infinity. So when we have a rational function, means both the numerator and the denominator are polynomials, and the degree of the numerator is less than the degree of the denominator. This is the case. The degree of the numerator is strictly less than the degree of the denominator. And we need to find the limit of the function as x approaches infinity. Then the limit is 0. The limit is 0, okay? So how do we understand that? When x approaches infinity, both numerator and denominator approaches infinity. But since the denominator has higher degree, the denominator approaches infinity faster than the numerator. So the whole function approaches 0. Another way to understand that is this. Okay, I'll show you this way. X approaches infinity, the function is x plus 7 over x squared plus 8. We are going to rewrite the function by dividing each part in the rational function by x squared. So x over x squared plus 7 over x squared. X squared over x squared, 8 over x squared. And we are going to simplify in the next step. X over x squared is 1 over x plus 7 over x squared. Denominator, this is 1 plus 8 over x squared, right? So when x approaches infinity, this approaches 0, this approaches 0, this approaches 0. The constant approach doesn't change, right? It's 1. So the limit is going to be 0 plus 0 over 1 plus 0, and that is 0 over 1, that is 0. This is one way to understand it. Faster way is to observe the degree of the numerator and the denominator. If the denominator has higher degree, then the function approaches 0 when x approaches infinity. Okay? Let me double check the entry. Yeah. Next. Question number 6. We have a piecewise function here, and we need to determine if the function is continuous at 3. All right? So we need to see, to determine if the function continues at 3, we need to look at the 3 parts, okay? Function when x approaches 3 from the left, the limit of the function when x approaches 3 from the right, and then the value of the function as x equals 3. So if all the 3 things exist and equal to each other, then the function is continuous at 3. When x approaches 3 from the left, okay, then the function is one third of x plus 2. Okay, and we are using the first piece because the function equals 1/3 times x plus 2 for x less than or equal to 3. When x approaches 3 from the left, x is less than 3, so we use the first piece. And the limit equal to simply plugging in x equals 3, okay? 1/3 times 3 is 1. So the limit of the function as x approaches 3 from the left is 3. When x approaches 3 from the right, we're going to use the second piece because when x approaches 3, this is 3, right? When x approaches 3 from the right, x is bigger than 3. When x is bigger than 3, the function is 2x minus 3. And how do we find this limit? Simply plugging in again, okay? Because they are all polynomial. 2 times 3 is 6. 6 minus 3 is 3. That's a good sign, right? Because the one-sided limit equal to each other. And what is f of 3? When x equals 3, f of x is 3. So as you can see, all the three things exist and equal to each other, so the function is continuous, all right? Is continuous. The given function is continuous at 3 because, yeah, I think it is A. Let me double check. It says not continuous, it's a not continuous. This is a continuous because f of 3 does not exist. Okay, so we're gonna have to choose A, right? Next. Question number 7. Find the simplified form of the difference quotient for the function 5 over x. Okay, this is to prepare for the definition of derivative. The function is 5 over x. And we're going to find the difference quotient, which is f of x plus h minus f of x all over h. Now we need to find what is f of x plus h. The input is x plus h, so we're going to change the input x as x plus h, all right? So the difference quotient, f of x plus h minus f of x all over h. We're going to plug in what we have. Denominator is h. Numerator, 5 over x plus h minus 5 over x. See the numerator as a difference of two fractions. In order to process this subtraction, we need them have the same denominators, okay? So we're going to have x plus h times x. This is 5 times x minus 5 times x plus h. In case you don't see it, you multiply this numerator top and bottom by x. You multiply this one top and bottom by x plus h. Then they have the same denominator. The denominator is x times x plus h. Numerator would be 5x minus 5 times parentheses x plus h, all right? Over h. So the numerator, denominator is x. The denominator of the numerator, the denominator of the top is x plus h times x. Numerator is going to be 5x minus distribute 5x minus 5h, all right? Don't forget the negative sign, negative 5x minus 5h. 5x minus 5x cancel, so we have a negative 5h. A negative 5h. I hope you can see that those two h's cancel each other, all right? If not, try use the keep change flip. So what we have is actually negative 5h over x plus h times x divided by h over 1, okay? So we know when we divide two fractions, we do keep change flip. So it's negative 5h over x plus h times x, change flip. And those two h cancel each other, right? So we have negative 5 over x plus h times x. Right? That's the answer. Okay, that's the answer. I'm gonna enter it here. Numerator is negative 5. Denominator is x plus h times x. Double check entry. All right, next. Question number 8. Let me maximize the page. List the points in the graph at which the function is not differentiable. Okay. Let's look at this graph, x0. So which point the function is not differentiable? We are looking for the point at which the function does not have a tangent line. Okay, this one, obviously, we can draw a tangent line easily, right? So let's look at x1. x1, the function is not continuous. So we have a very important conclusion here. Differentiable implies continuous, okay? If a function is differentiable at a point, then the function must be continuous at the point. The counterpositive of this statement is if it's discontinuous. If it's not continuous, then it's not differentiable either. Okay? If the function is not continuous at a certain point, then the function is not differentiable. This is pretty important. I hope you'll remember. If the function is differentiable, then the function must be continuous. Okay? And the counterpositive of this statement or theorem is if the function is not continuous, then the function is not differentiable at that point. So this function is not continuous at x1, obviously is not differentiable at x1 either. Where is x? Okay, here. We're going to click on that. What about x2? Is not continuous, right? Because there's a hole here. So we're going to click on x2 as well. Function is not continuous at x2. So the function is not differentiable at x2. What about x3? It's continuous, but it's not differentiable, okay? So what is the name of that? It's called a cusp. Yeah. So if you see something like this, like that, then the function is not differential at that point. Okay, yeah, there's a name for that, the cusp. This is an angular point. Why? Because you are not able to find a tangent line. Okay, the tangent line does not exist. All right, so that's an easy way to tell. Obviously, this is a cusp. The function is not differentiable. X sub 3, click on it. X sub 3, oh, it's right here. What about x sub 4? A hole, not continuous, not differentiable. We're going to have to click on x, select x sub 4. X sub 5 is fine. Yeah, that's it. Okay, we have 1, 2, 3, 4. We have 1, 2, 3, 4. Let's double check our selection. 1, 2, 3, 4. Okay, next. Question number 9. Piecewise function. Is the function continuous at 3? So the limit, the left limit, plug in 3. 3 squared is 9. 9 plus 4 is 13. From the right, plug in 3. 3 times 3 is 9. 9 plus 4 is 13. It is continuous, okay? It's continuous. Use the same method we used earlier. We had a similar problem earlier. Yeah, the part B is about differentiable. Is the function differentiable at 3? No, okay? Is because the first piece is a quadratic function, is a parabola. The second piece is a linear function, is a straight line. You will see something like this, okay? and something, yeah, if what let's draw the graph for this piecewise function. 1, 2, 3 at x equals 3 is 13, so around here. X squared plus 4, 2, 3, 4, something like this. And 3x plus 4. Okay, it doesn't have a tangent line. Similar with the cusp or angular point, two curve where the two curve meet is not differentiable. Two straight line where the two straight line meets not differentiable. This one is a curve and a straight line, right? Curve and I don't know exactly, but is one part is on one side of the point is a curve, on the other side is a straight line. So similar with the cusp or angular point is not differentiable, okay? It's not. It is continuous, but not differentiable. Yeah, we mentioned if it's differentiable, it must be continuous, okay? But if it's continuous, does not mean it is differentiable. So one direction. But if it's not discontinuous, if it's not continuous, definitely not differentiable. So we have to look at a specific situation. So it's continuous, not differentiable. Next. Question number 10. Differentiate this function. All right, this is a polynomial function. You should know the very basic formula for power function, right? If we have x to the power of n, then the derivative of this function is n times x to the power of n minus 1. Very basic. All right, that's the formula we need to use. So for this function, we have 1, 2, 3, 4. 4 power function in the polynomial. The first one, 3. The coefficient 3 is going to remain the same, okay? X cubed. The 3 going to move in. Let me just write it down here. Yeah, the 3 going to move in front. So the function y equals 3x cubed minus 17x squared plus 63x plus 4. We're looking for the derivative, so keep the coefficient and use the formula. Bring down the exponent in front, and then copy the variable base. And the 3 minus 1 is 2, okay? Yeah. Similarly, minus 17, coefficient stay where it was, and x squared, 2x, because 2 minus 1 is 1, so you have a 1 here, exponent. And next, 63, all right? Since this degree is 1, and 1 minus 1 is 0, x to the power of 0 is 1, so you don't have the variable x in. And the constant, when you take the derivative of a constant, you have 0, right? And you simplify, 3 times 3 is 9, x squared minus 34x plus 63, right? So we're going to put it here, 9x squared minus 9x squared minus 34x plus 63. Next, question number 11. Find the derivative for this function. Let's see. Y equals 50 over x to the power of 9. That actually is 50 times x to the power of negative 9. Will you remember the negative exponent formula from algebra 2? All right, so we write this function as a power function form that we can apply the formula, this formula. So the derivative is going to be keep the coefficient, and move the exponent in front, and then keep the variable base and use the original exponent minus 1. And that gives 50 times 99, negative 450. And the x to the power of negative 10. Negative 9 minus 1 is negative 10. Okay, so the derivative is negative. Okay. So here I would recommend you write the answer as negative 450 over x to the power of 10. Because an expression, algebraic expression with a negative exponent is not considered as simplified. We want to give the answer in the simplified form. So we are going to have negative 450 on the top. And we are going to have x to the power of 10 in the bottom. This is what we get. Okay, very good. Next. Question number 12. Find an equation for the line that is tangent to the curve at the point -1, 0. All right, so this is a very classical type of question, very important question. So the function y is 2x cubed minus 2x cubed minus 2x. So the point is here is -1, 0, right? So we want to find the equation for the tangent line at -1, 0. So our goal here, we're looking for a straight line, okay? Straight line. And obviously, we need to write a straight line in the slope-intercept form. Do you guys remember the slope-intercept form? Y equals mx plus b. So we need to know what's the m, what's b, right? M is the slope of the line, which is the same with the derivative of the function at x equals -1. Okay, so slope of the tangent line is the derivative of the function at -1 in this case. All right, so let's see what is the derivative. The function is very simple, the polynomial. The derivative of the function is 3 in front. 2 times 3 is 6. X squared minus 2. All right. Yeah, so the derivative is 6x squared minus 2 when x equals -1. So we're going to plug in x equals -1. -1 squared is a positive 1. So 6 minus 2 is a 4. Yeah, 6x minus 6x squared minus 2. And plug in x equals -1. We get a 4. So the slope is a 4. All right. So the equation of the tangent line is y equals 4x plus b. Now, how do we find the value for b? If we know the b, then we know the answer, right? We're going to plug in the given point -1, 0. We're going to plug in -1, 0. That means x equals -1, y equals 0. All right? Because this point is on the tangent line, it will satisfy the equation. Y equals 0, x equals -1 plus b. 0 equals 4 times -4. Sorry, 4 times -1, -4 plus b. So b has to be positive 4. So we got that m equals 4, b equals 4. The answer is 4x plus 4. 4x plus 4, right? This is a very good question. -1, -4 plus 4, 0, and the derivative is 4, 6x squared minus 2. Plugging x in, it's 4. Yeah, that's it. You can rewind it to see the process of solving that type of problem. Here is number 13. In T years, the population of a certain city grows from 200,000 to a size P given by this function. This function is polynomial, quadratic. Find the growth rate dp dt maximize it. Okay, so the part A. Part A is to find the derivative, right? T here is the independent variable. So the first term in the function is a constant. When we take the derivative, the constant is 0. The derivative of a constant is 0. And in this one, the coefficient 9,000 stays. T squared, the derivative of t squared is 2t. Okay, so the derivative is 9,000 times 2t, which is 18,000 t. 18,000 t. Double check. So we're going to take the derivative of the function, okay, with respect to t, the independent variable. This part is 0. This part, when we take the derivative, we have 0. And this part, 9,000 going to stay as the coefficient. The derivative of t squared is 2t, because you move 2 in front, and 2 minus 1 is 1, so 2t. And 9,000 times 2t is 18,000 t. So that's the derivative. Okay, that's the rate of change of the population at a t. Part B is to find the growth rate at a t equals 15. Part B is finding the population after 15 years. Okay, so to answer part B, we use this function. That's the population when t equals, after t years. So the population after 15 years, simply plugging in t equals 15 here, all right? So we're gonna have 200,000 plus 900 times 15 to the power 2. And use calculator to do that. It's 15, right? 15 squared times 9,000 plus, I don't remember exactly what is that. 200,000 plus 200,000. Double check. 200,000 plus 9,000 t squared. 200,000 plus 9,000 times t squared. T is 15. And it is 2225. 30225. 2225. So double check your entry. Make sure you have. All right, part C. The growth rate at t equals 15. To find the part C, we need part A. Okay, that's the growth rate function. So we're gonna plug in t equals 15 here. Okay, we're gonna plug in t equals 15 in this function to find the growth rate at t equals 15. So that's gonna be 18,000 times 15. 18,000 times 15. 18,000. 18,000 times 15. 270,000. So 2740. 270. And 234. Okay. Part D. What is the meaning of the answer to part C? The growth rate tells the rate at which the population is growing at a time t equals 15. That seems right. Let's also look at a BCD. The growth rate tells the difference But no, it's not that. The growth rate tells the rate at which the population is growing at time 14. No. The growth rate tells the average growth. No, it's instant. Okay, instant. Instant rate of change. The derivative is instant rate of change. Okay, make sure the calculation is correct. 18,000 T times 15. This one is 2. Okay, next. Question number 14. We have a function. The structure of the function is a product. I think we are going to use the product rule to process this question. So I'm going to use y to replace g, okay? I'm going to give g a different meaning, or just forget about this g. So y equals x to the power 95 plus 3 times x to the power 93 plus 5. I'm going to write this function as f times g. As I said, I use g as a different meaning, all right? Because our formula is f times g prime. The derivative of f times g is f prime times g plus f g prime. Okay, so we need to find the f prime. If f is x 95 plus 3, let me write it in organized. So here we have f is x to the power 95 plus 3. G is x to the power 93 plus 5. Okay, then f prime is, this is a power function, right? Use the formula we have already. 95x to the power 96, because 95 minus 1 is 96. The 3 is a constant, the derivative of constant is 0. Okay, so that's f prime. That's f prime. What about g prime? Similarly, we can find g prime, 93x to the power 94. 5 is constant, the derivative of 5 is 0. So now we have all the 4 parts. Y prime, which is f g times g prime, which is f prime times g plus f times g prime, is going to be f prime, so 95 x 96 times g times g. G is, actually, I changed my mind. Yeah, let me use this method, and then we actually have a better method for this problem. We don't have to use the part of the rule. If you FOIL first, okay? Yeah, let's use 2 different methods for this problem. G is x 93 plus 5 plus f x 95 plus 3. G prime is 93x 94. And then we're going to have to distribute anyway. So this one gives 95x 99 minus 25x 26. This one gives 93x 99 minus 9x 94. We simplify, we have 98 x 99, and this one is 25 x 96, 99 x 94. Which one is the same as this one? 98, 99, 25, 99 x. This one, right? 99, 96, 99, 96, 94, 25, 99. Yeah, let's use a different method. So the general rule is if we can make the original given function simple, we're going to do that first. So for this specific question, we should have done that. So I recommend you use this method, okay? FOIL first. X 95 times x 93 plus 5 times x 95 plus 3 times x 93 is 15. 3 times 5 is 15. So we have this one is x to the power negative 8, right? Part of the rule, 95 plus 93, negative 8, and plus 5 times x negative 5, 3x to the power negative 3 is 15. And then we take the derivative. This is a lot easier than the first problem. So we take the derivative, negative a, x, negative a minus 1, negative 9. This one, 5 times 5, 25, negative 25, x, negative 5 minus 1, negative 6. Here, 3 times negative 3, negative 9, x, negative 3 minus 1, negative 4. 15 constant, derivative 0. It's the same with what we had earlier, obviously. Yeah. So that's good. We practice. Oops, this is a mistake I want to remind you not to make. We decide to choose which one? C, right? C is the one. Yeah, sometimes when you are not careful, you actually you click other answer. So be very careful, be aware of this. You click here, that's fine, right? Or here, it doesn't matter. But if you randomly click here, and you actually choose a different answer, when you actually want to choose a C, just be aware of that, not to make that mistake. Next, question number 15, derivative. This is we want to use the quotient rule for this one, okay? You remember the formula for quotient rule? If y equals f over g, then y prime is g squared f prime g minus f g prime. So that's the formula, okay? Quotient rule. So our f numerator is x cubed. Our g, the denominator, is x minus 1, okay? So f prime is 3x squared. G prime is 1, actually, okay? And because linear, the derivative actually is the slope, which is 1. All right, so let's plug in the formula. The denominator is g squared, so square of x minus 1. Numerator, f prime times g minus f prime times g minus g prime, or f times g prime, which is 1, okay? This is squared. We're going to simplify the numerator. Distribute. 3x squared times x is 3x cubed minus 3x squared, and then minus x cubed. So those two terms can be combined as 2x cubed minus 3x squared all over x minus 1 to the power 2. Let's see which one is the same as this one. 2x cubed minus 3x squared, x minus 1 to the power 2. This is the one, right? 2x cubed minus 3x squared all over x minus 1 squared. So we want to choose B. Choose B. Next. Question number 16. Differentiate. For this problem, since the degree is 5, I do not recommend you expand it and then take the derivative. I would say use the product rule. So this problem actually is designed to apply the product rule. We use product rule. Y equals x times x squared plus 6 to the power 5. Right? Here, f is x. F is x. G is x squared plus 6 to the power 5. Okay? What is f prime? F prime is 1. That's very simple. What about g prime? To find the g prime, we need to use the chain rule. Did we learn chain rule here? Yeah, we have to use the chain rule here, okay? Yeah, how do we find the chain rule? So the outside function is a power function, u to the power 5, okay? Yeah, so we can, let me use a different color. So let y be, let's only focus on this problem, this part. Let's y be u to the fifth, and u is the base x squared plus 6. Then dy dx is dy du times du dx. So two lengths, right, in the chain. Dy du is a 5u to the power fourth. Dy du dx is 2x, right? 2x. And then go back x, u is x squared plus 6. So x squared plus 6 to the power 4 times 2x. Simplify, we have 10x times x squared plus 6. So this part, we have 10x times x squared plus 6 to the power 4, right? We apply the chain rule here. 10x times x squared plus 6 to the power 4. This part is the difficult part. You can rewind to look at this part, the red part. Once we have f prime, g prime, we can apply the product rule. So y prime is f prime g plus f g prime. F prime is 1. 1 times g, which is x squared plus 6 to the power of 5, plus f, which is x times g prime, which is 10x x squared plus 6 to the power 4. This question is challenging because it's not multiple choice question. You really have to provide the correct answer. Let me double check. F prime g plus f g prime. Okay, now we are going to simplify the expression. X squared plus 6 to the power 5. This one is 10x squared. X squared plus 6 to the power 4. We are going to take out the common factor, okay, GCF. So x squared plus 6 to the power 4 is the GCF of the two parts. And in this part, we factor out fourth power. So we have x squared plus 6 to the power 1 left, okay? And plus 10x squared, because this part is factored out in a bracket. X squared plus 6 to the power 4. I'm going to simplify the expression in the bracket, combine the like terms, x squared, 10x squared, that gives 11x squared plus 6. 11x squared plus 6. Okay, so that's our answer. X squared plus 6 to the power 4. Oh, x squared plus 6 to the power 4 times a factor, linear factor, what is it? 11x squared plus 6. 11x squared. Six. Let me look at x squared plus 6 to the power 4. 11x squared plus 6. It's good to always double check just in case we make any mistakes. Still fine. Okay. So next, question number 17. Differentiate the function. We use a chain rule for this one, okay? Chain rule. Obviously, this is a composite function. You can see that as two layers with inside function the inside function is a quadratic function. The outside function is a power function. Okay, so if we let u be the function in the parentheses, if we let the u be 2x squared minus 5, then the original function is y equals u to the power of negative 12. So this is the outside function, this is the inside function. Very important. You should always use the process I'm using to process the chain rule problem. And now we're going to find dy du. Negative 12 times u to the power of negative 12 minus 1, so that gives negative 12 u to the power of negative 13. Okay, and then we're going to find the du dx. 2 times 2x, negative 5 is constant, the derivative is 0, so it's 4x. So the original function has a derivative dy dx, which is dy du times du dx. dy du, negative 12 u to the power of negative 13, du dx, 4x. Negative 12 times 4 is negative 48x u to the power of negative 13. U did not exist in a function in a problem, right? So we have to go back x. Negative 48x. U is 2x squared minus 5 to the power of 13. Yeah, 13. Right? 2x squared minus 5 to the power of negative 13. Because negative 12 minus 1, negative 13. 4x. 4x times negative 12. Negative 48x. That's correct. Negative 48x times parentheses to the power of negative 13. Inside the parentheses, we have 2x squared minus 5. Double check. Ooh, always make that mistake, right? Careful. Minus 5. See if it's the same with negative 48x. 2x squared minus 5 to the power of negative 13. Okay. Next. Differentiate the function. Chain rule again. I'm going to use the chain rule again. Okay, so we're gonna have y equals x plus 7, x minus 4 to the power of 3. The outside function is a power function. Okay, the inside function is a rational function. So we let u be the stuff inside the parentheses. Then the original function is y equals u cubed. dy du, 3u squared. du dx, we're going to use quotient rule, right? Denominator to the power of 2. The derivative of the numerator times denominator minus numerator times derivative of the denominator. So let's simplify x minus 4 to the power of 2. This x minus x cancel, negative 4 minus 7, negative 11. Let me double check. It's minus 4 to the power of 2. X minus 4 minus x minus 7. Yeah, be careful here is negative x minus 7, okay? So x is gone. Negative 4 minus 7, negative 11. So that is du dx. So dy dx is dy du times du dx. And u is x plus 7 x minus 4 of 2 times negative 11 x minus 4 to the power of 2. So now to simplify the expression, it's a challenging one. It's not multiple choice question. You need to type exactly the correct answer. So we have negative 33 x plus 7 to the power 2 x minus 4 to the power 3 x minus 4 squared. Fourth power, it's not fourth power. X minus 4 to the power 2, x minus 4 to the power 2 is fourth power. X plus 7 to the power 2. 3 times negative 11 is negative 33. Let me double check. Negative 33. Squared, first power. All right, next. Chain rule again. Outside function, rule U. Inside function, x squared plus 11. dy du. This, you need to, I strongly recommend you remember this formula. Yeah, I would recommend you remember this formula. Which formula? The derivative of rule x is 1 over 2 rule x. It is so important, so frequently used. You should memorize it, okay? That's why I know the derivative of dy, the derivative of y with respect to u, dy du is 1 over 2 rule u. And du dx, 2x plus 0, so 2x. By the chain rule, dy dx equals dy du, du dx. Two x over 2 rule u, 2 cancelled. So x over rule u. U is x squared plus c. So this is the answer. X over rule x squared plus 11. Double check. Next. Question number 20. Horsepower, okay? This very simple power function. Y equals x to the power 5th. 1 prime 5x to the power 4th. Double prime 4x cubed. That is 20x cubed. Triple prime 23x squared. That is 60x squared. Horsepower 62x, which is 120x. Yeah. Actually, I don't know if you noticed, actually, this one is, there's a pattern here. 5 times 4 times 3. And here actually is 5 times 4 times 3 times 2. So here is so 5 times 4 times 3 times 2. So that gives 120. Yeah, 120x. 120x. Question number 21. It's an application problem. So this is a distance function. We know velocity function is the derivative of the distance function, right? And the approximate acceleration function is the derivative of the velocity function. Let me write it down. I'm talking about. So here we have three functions involved, this type of problem. Distance function, normally we use t, time, independent variable. Velocity function, acceleration function, right? So what's the relationship between those three functions? Velocity function is the derivative of distance function. Acceleration function is the derivative of velocity function. So acceleration function is double prime of s. Okay, so that's the relationship between them. Okay, so here we have the distance function equals, what is that? 4.905. 4.905 t squared. So the first, two parts. The first part is to find the velocity, right? So S sub t in meters, if a stone is dropped from a cliff, assuming finding the velocity of the acceleration after it had been falling for 8 seconds. So t equals 8. T equals 8. T equals 8. So the first part is actually finding v of 8, which is s prime of 8, right? Okay, so since s of t is 4.905 t squared, then the velocity function would be the derivative of s, which is 4.905 times 2t, which is 9.81 t. Let me double check. 4.905 times 2. 4.905 times 2. 9.81. 9.81 t. 9.81 actually is the gravity, right? Free fall. Okay, so then the first part would be plugging in t, 9 times 8. 8, oops, sorry, times 8. What is it? 78.48. Velocity, 78.48 meters per second. After 8 seconds. Yeah, that's correct. And second part is to find the acceleration when t equals 8. We find the acceleration function first. Acceleration function is the derivative of the velocity function. So it's just the coefficient, right? coefficient, 9.81. 9.81. So it doesn't matter what t equal to. The acceleration is 9.81 because of free fall. 9.81. Question number 22. Double prime. This is not difficult. Y equals 7x to the power of -3. First, the derivative, move the -3 in front. X, -3 minus 1. 7 times -3, -21. X to the power of -4. Double prime, keep the coefficient, -4. X, -4 minus 1. -21 times -4 is a positive 84. X to the power of -5. Right, you would wonder, should I enter this way? Because I mentioned negative exponent is not simplified, right? I wouldn't mind in this case because the function is given. The original function has a negative exponent. So I would just enter this as the result. If the original function does not have a negative exponent, I would recommend you enter the result without a negative exponent. So 84 x to the power of -5. Negative 21, 94, negative 21 times 94, 84, x to the power of -5. Yep, that is correct. Next. Question number 23. Jimmy decides to earn money. Cost function, okay, initial cost, 250. Electricity and maintenance costs are $5 per lawn. Complete part A through C. Part A, formulate a function for the total cost of mowing X lawns. So reading the question, you'll see this is a linear model. Okay, even without having any business, you already put money by the mower, right? So that's 250. That's the initial cost, and it costs more when you mow more lawn. So plus $5 per lawn. So 5 is the rate of change, 5x. Okay, 250 plus 5x. Well, if you enter 5x plus 250, I don't see the difference. Should be the same. 250 is the initial cost. 5 is the rate of change. Yeah, the cost per lawn. X is the number of lawns, so 5x. B, Jimmy determines that the total profit function for the lawn mowing business is given by P of x equals 7x minus 250. Find a function for the total revenue. Okay, so we are looking for revenue function. So the connection is the revenue function. The revenue function, I remember this. Revenue function is okay. So the profit function, how about that? Profit function is a revenue function minus cost function. Okay. So the revenue function is the profit function plus cost function. If you rearrange the terms in this formula, revenue is profit plus cost. So you just need to add the cost function and the profit function together. 5x, 7x, that is 12x. Negative 250, positive 250, cancel. So that's the revenue function. The revenue function actually tells every time you mow one lawn, you get a $12. So how much does Jimmy charge per lawn? $12. It's linear as well, right? When the number of lawns is 1, the revenue is $12. When the number of lawns is 2, the revenue is 12 times 2, so $24. That means that each lawn, the Jimmy charged $12. How many lawns must Jimmy mow before he begins to make profit? There's a break even. To find a break even, you make profit equals cost. Okay, hold on. To find, yeah, you're gonna equate this function with this function. Make C and P equal to each other. 7x. Make P and C equal to each other. What is P again? 7x minus 250. 7x minus 250. C cost function is 250. 5x plus 250. Solve this linear equation. Right? Minus 5x minus 5x. 2x plus 250 plus 250. 500. So x is 250. X is 250. He has mode 250 in order to break even. Let's see. Yes, because because the mower costs $250. 250 divided by 12. And Jimmy moved before begin to make a profit. So he charged $12. So the profit minus the 5 is actually $7 only. $7. 250 minus 7. 7 divided by 7. 35. Something, let me think. 7x profit. Oh, okay, hold on. My bad. Break even. I think break even is start to make a profit. So my bad. So break even is to make revenue equals cost. I apologize. Okay, revenue is 12x, cost is 250 plus 5x. So 7x equals 250. 250 divided by 7. 36. 36. I apologize, but I figured out because I just try to make sense of the result, right? He charged $12, but the cost for each time he mow a lawn is $5. So the profit for mowing each lawn is $7. But up front he spent $250, right? So he has to mow at least this many lawns in order to get the money he invested in the device back, right? So 36 he start to make money. All right, so yeah, again, to find a break even, we make the revenue equals the cost. So when the revenue bigger than the cost, the profit become positive, right? Because the profit is revenue minus cost. So when the revenue is less than cost, your profit is negative, right? When the revenue equals cost, your profit is zero. When your revenue is bigger than the cost, you start to make positive profit, you start to make money. All right? Okay. Question number 24. A farmer buys a new tractor for that much money and assumes that it will have a trade-in value of $81,000 after 10 years. The farmer uses a constant rate of depreciation to determine the annual value of the tractor. Complete Part A and Part B. Part A, find a linear model for the depreciated value V of the tractor T years after it was purchased. It says the rate of depreciation is a constant. We need to find that first. That's going to be the slope of the model, linear model. So after 10 years, the trade-in value is 81,000. Originally is 145,000. So how much is the depreciation in over the 10 years? We use 145,000 minus 81,000. That is 64. 145 minus 81. 64,000. 64,000 in 10 years. Over 10 years. I need to take notes. 145,000 minus 81,000. 81,000 over 10 years, right? And you divide it by 10. Each year, the depreciation is 6,400. So that's going to be the slope, okay? Just write it down. And initial value is 145,000. Since depreciation is negative, so minus, what is the slope again? 6,400. Yeah, has to be negative. Okay, the slope is negative actually. Negative 6,400. We use X or T. Find a linear model for the depreciation value V of the tractor T years. Yes, we're going to use T. All right. So when T equals 10, that is 64,000. 145,000 minus 64,000 gives 81,000. So that's correct. Initial value is this. What is the depreciated value of the tractor after 6 years? So part B is to use the result from part A. Use the model to find the remaining value after 6 years. So plug in T equals 6 here. Plugging in T equals 6 here. So I'm going to use a calculator. 145,000 minus 6,400 times how many years? 145,000, 6,400, 6 years times 6, right? 145,000 minus 6,400 times 6 equals 106,600, $106,600. 106,600. 106610. Oh, sorry, 00. 10. 6600. All right, next. 25. Rewrite the following as an equivalent expression using radical notation. Okay. So this is what we do. Okay, click this one. You're gonna know the denominator of the exponent. The exponent is a rational number, right? It's a fraction. Numerator is 8, denominator is 9. The denominator goes to here as the root number of the radical. 9. And the radicand and the radical symbol, you're gonna have t to the power of 8. So basically, the denominator of the exponent goes here as index. The numerator of the exponent remain on the shoulder of t. Right? This is the formula. This one is the same, but we need to remove the negative exponent first. So we're gonna have the reciprocal of y to the power of 6/7, which gives 7 as the index. 7 is the index. And the radical, we have a y to the power of 6. All right. In this one, we firstly remove the negative exponent by taking the reciprocal 1 over. The denominator is going to be y to the positive 6/7. And 7 goes to here, 6 goes to here. I'm trying to, the formula we use is this. X m over n equals n's power x to the power n. Okay, that's the formula. If we have a negative exponent, this is how do we remove the negative exponent. That's the two formulas we used for the previous problem. Now, next question number 27. Demand function, supply function, the equilibrium point. Just make the two functions equal to each other, okay? Yes, yeah, when the demand equals supply, make the two functions equal to each other. I believe you know how to solve the equation. 18,300 minus 60x equals 300 plus 60x. So we have this burner here, we have 420x. Bring this here, we have 18,000. So 18,000 divided by 120. 150. The number of units, when they produce 150, the demand equals the supply. That's how the equilibrium point is reached. Okay, double check 120, 18,000, 120, 18,000 divided by 120. Okay, that's correct. Next, question number 28. This is from the review chapter, right? 2 to the power of x equals 13. We're going to apply ln on each side. Ln to the power of x, ln 13. Okay, and by the power rule, you took pre-cal maybe, or functions. If you remember the power rule, the exponent in the argument can be taken outside in front of ln2. And you have ln 13. And ln2 is just a number, and you divide each side by ln2, cancel. You have x equals ln 13 over ln 2. And use a calculator. Ln 13 divided by ln 2. Don't forget to close the parentheses. 3.7004. 4 decimal places. 3.7004. 3.7. This is not a calculus problem. This is a pre-calc problem. 3.7004. Right? Yeah, also be careful. You click on, if you click here, you mistakenly made a mistake. You actually want to choose A, right? Next. This one is the same problem. 2 to the power of x equals 24. Ln 2 to the power of x equals ln 24. And this x can be brought in front of the log. And we have x times ln 2, ln 24. And then we divide each side by ln 2. Cancel, we have x isolated, so we have ln 24 over ln 2. By the way, you do not have ln 12, okay? That's an incorrect formula. Your result is ln 24 over ln 2. Ln 24 divided by ln 2. My bad, sorry. Ln 24 divided by ln 2. 4 decimal places, this one is going to be 0 because 6 is bigger than 5. 4.5850. Next. Question number 30, almost done. For the scatter plot, okay. Determine which of the following types of functions might be used as a model for the data. I would say linear. Obviously, it's not parabola, right? So you do not choose quadratic. It's not exponential either. I would use linear. Since it's going up, the slope is positive. Polynomial, neither quadratic nor linear. Quadratic, not quadratic. Not exponential. Yeah, I would just choose linear model. This could be a linear model. Linear model. Not quadratic, not exponential. Okay, D. Question number 31. For the graph, determine which of the following function might be used as a model. This is a parabola. Yeah, this is obviously, this cannot be a linear. This is a parabola facing downward. Quadratic. The leading coefficient has to be negative to make the graph open downward. If the leading coefficient is positive, it's open up, facing up. So open upward. So we're going to choose this one, quadratic, leading coefficient negative, so going down, right? Last one. Yeah. What happened? Oh, okay. So for the graph, determine which, if any, of the following functions might be used as a model for the data. It's not quadratic, obviously. I don't think this is a exponential decay because it's pretty mild. It's more like linear. I'll choose linear again. All right, let's see if we make any mistakes here. Oops. Let's see which one. This one. differentiable at 3. Okay, so let's see what's the other one. We made a mistake. It's number 27. Oh, okay, this is my bad. The equilibrium point has to be, okay, we need to read this. Type and word the pair. Do not include $sign. Yeah, so we have x equals 150. We have to plug in x equals 150 to have the supply or the demand, which is 9,300. And you use 150 as the first component, 9,300 as the second component. Yeah, so do not make a mistake like what I did. Yeah. And for that differentiable problem, let's see. Number 9. Oh, I say it's not differentiable. Did I think I I think I just clicked the wrong one. I mentioned this is not differentiable, right? I said this is continuous, but not differentiable. It's not differentiable because it's in something like a cusp, is a curve and a straight line, something like that. I said it's not differentiable. I think I just clicked on the wrong answer. Yeah, so be very, very careful. Be very, very careful. Do not make a mistake like that. Yeah, let's emphasize question number 27. You do not enter the information in the parentheses actually is very important. Yeah, they ask you to type and order the pair. So we have to type and order the pair here. All right, that's everything. I'll see you in the next review.